Alright, hello, welcome to this video. Today we're going to be going over the Pythagorean theorem. We're going to use this for doing calculations about right triangles. So first question to answer is, what is a right triangle? You'll see I have one drawn right here. This type of triangle is a special triangle, the right triangle. You can have triangles of all different shapes. For example, you could have a triangle maybe that looks a bit more like this, where it's not necessarily going to be a right triangle. My software has corrected it to be so, but you can see there will be many different types of triangles that we can draw where they're not all going to have this angle right in here. Now that angle is going to be our 90-degree angle. So the thing we want to focus on here is what type of triangle we're dealing with, and then being able to determine what set of rules we can use to work with our triangle. So for this type of triangle, since we do have this angle here, now this little box I've drawn, this says that the angle theta, we usually give angle with theta, is that equals 90 degrees. So that means that, let me see here, that means that the angle between this piece and, let me see, this piece and this piece, this angle right here is equal to 90 degrees, okay? So working with that now, we can say that we know we have a right triangle, which means we can follow the Pythagorean theorem, which states that a squared plus b squared is equal to c squared. And what does that mean? Well, c squared, this term on this side, we know that that always refers to the longest side of the right triangle. We call it the hypotenuse. You don't necessarily need to remember that for right now. It's not the most important thing, but it means this side. I'll put in red. It's referring to this piece right here, the piece in red. So I'm actually going to go ahead and draw c squared in red. And what about a squared and b squared? Well, it doesn't really matter how you refer to them specifically. A could be either this side or this side. It doesn't really matter. I'm going to say that a is this side, the side I'm going to put in green, okay? So we're going to rewrite that in green now, and we'll get one more color for B. Let's go with purple, and we'll see that the other side then must be this B squared, so that's going to be in purple to match the side color. So let's work with that now. Let's go ahead and test to see if this triangle that I've drawn is an actual right triangle. So let's plug in the values. So what is A? Well, we know that this is A, there we go. This is B, since we have the colors written right there. And C is always the long side. So we'll plug in our values. So we know that we have 4. Oh, that shouldn't be raised to the 4. That should be squared. We should have 4 squared plus 3 squared equals 5 squared. Okay. So now you can see all we've done is exchange this a value, for example, with the value that we're given for a over here. And similarly for b, we've simply plugged in 3 in exchange for b, because we know that b right here is equal to 3 right here. And then we did the same thing for 5. We know that 5 equals c, so we just put that in for c. And you'll see that's what we get right in here. So you can get your calculators out, or you can do it in your head, whichever is easiest for you. We know that 4 squared means 4 times 4. So 4 times 4, that equals 16, plus 3 squared. Well, 3 squared is 3 times 3, and 3 times 3 equals 9. And 5 squared is 5 times 5, and that equals 25. And now what's 16 plus 9? Well, you do that out, and you find that that is 25, and equals 25. So this is true. When this is true, we can give it a little check mark, and we know that we do have a right triangle and that we've done the math correctly. Now, the reason this is useful is for when we want to, for example, learn one of the sides that we're not given. So I'm going to draw another right triangle. Let's put this in blue. Here we go. Here's another right triangle. And then it'll correct that for us. Okay. So let's see. We're going to have a triangle. Let's say I'm going to have a 1 on this side and a 2 on this side, for example. And we need to figure out what this side is. And the way that we're able to do that is by using this Pythagorean theorem. So let's go ahead and write it out again, just so we don't forget. I'll put it in green. So we know that a squared plus b squared is equal to c squared. And now, if you remember, a and b don't particularly matter which of the short sides are referring to. This could be a, or this could be a, and similarly for b. However, we know that this question mark side, we know that that equals c. So we can plug in the others. Let's say that 1 equals a, and let's say that 2 equals b, in order to plug it into our equation. So we put these in. So if a is 1, then we have 1 squared plus, and then b we know is 2 now. So b is equal to 2, so we get 2 squared is equal to c squared. And we know that that's the side that we're trying to solve for. So let's do this math out. 1 squared is 1 times 1, which is 1, plus 2 squared is 2 times 2. 2 times 2 is 4. And we know that that equals c squared. We can't do anything else with this c squared because we don't have any numbers for that. So from that, we know that c squared is equal to 5, because 1 plus 4 is 5. And now, we can't say that c equals 5, because it's c squared that equals 5. We've got this little 2 up on the top. So in order to get rid of this 2, we need to somehow take a square root of this c, and then we can find what its value is going to be. Because we know that right now this is saying that c times c equals 5. So we need to separate these out. So we need to say that c equals the square root of 5. And the way we could check that this is true is that if we square both of these sides now, like this, square both of them, we can say again that c squared is equal to 5. Because when you take the square, and when you take the square of root 5, we're going to see that this just equals 5 again. So you don't have to worry about that too much. That might seem a bit abstract depending on your experience, but we can say that c equals the square root of 5. Okay? So that's how you're going to solve problems like that. You can similarly do that if you don't know one of these a or b sides. If you're not given one of those sides, that's not a problem either. You just say, if you don't know b, for example, then you plug in what you do know for a and c, and you move things around that eventually solve for the variable that you don't know. The one big key thing to remember is to get rid of this 2, to get rid of this square, we need to take square root of both sides. So writing that out, it looks like the square root of c squared is equal to the square root of 5. And we know that this square root means just raising something to a half power. So it's c squared and then raised to half power equals 5 raised to the half power. And then working that further, we can see that when this 2, I'll put this in purple, when this 2 right here and this 2 right here are multiplied together in these exponents, we're going to get just c to the 1 power, which we can just simply write as c instead. We don't need that 1. And we see that that equals 5 to the half power, which is the same thing as writing root 5. Okay, so that's how you're going to do problems like that. Look for one of those on the quiz, and hopefully this makes sense. Thank you.